Okay, we're going to be analyzing the characteristics of graphs and all the parts thereof. So, this is kind of where you start like that. We're going to be looking at this graph. All right, couple of definitions. An x-intercept is where the graph crosses the x-axis. Remember, x-axis is your horizontal. And the y-intercept is where it touches your y-axis. Well, right here, we have a y-intercept at this point. This is at 0, 3, because we didn't go left or right. All your y-intercepts will have a 0 and then whatever it is, okay? Now, your x-intercepts, for this one we have 2, okay? And I know the graph doesn't look like, it doesn't look exactly like at those points, and I'm not going to guess decimals, but we're going to say that this is -4, 0, and 5, 0. All right, that's what we're going to say right now. This is not a very good graph, but this is what I have, and this is what we're going to go over. Okay, and that's it. It's just where the graph touches those axes. Okay, now the maximum. The maximum of a function is the largest value, remember, of your output or your range. All right, minimum is the smallest function value. Again, output range, that's your y value. All right, right here, it says the maximum occurs at x equals -2, and this, not a fan, okay? If this is my highest point, I'm going to say my max is -2, 6. And that's kind of how I want you to do your max. I want you to do your max as a, coordinate point. All right. Now, this is a minimum occurs at -4, -3. Again, Mr. Jeffrey's world, this is what we're doing. Okay, it's -4, -3. Now, I don't need all this. I need this. Okay, keep it simple. All right, increasing is when it goes up. Now, this is read from left to right. Okay, and decreasing is going down from left to right. It's kind of like positive and negative slopes, if you may remember some of that. Now, for instance, where is increasing? Okay, on this part, it's increasing, and we would say that's between this point right here. This is -6. It's less than x, and it goes all the way up to where x is -2. This is on this x value right here. So this is where we would say this is an increase. Okay. Now for our decrease, we actually have two different ones. Okay, we have our first one from right here, from -2 to 2. And there's a reason we don't have the lines up underneath them, is because they're not crossing the x-axis right there. Okay. And then we also have another one from 5 to 6. Okay. Or you could say like from -2, or you could actually say from x equals -2 to 2. That's basically the same way. All right, but sometimes most of the time you'll see them as these inequalities. All right. Now, here's an example. All right, is the graph increasing from x equals -2 to 0? So here's -2, here's 0. We're looking at this area right here. Okay, that's the area we're looking at. Is that going up or down? Well, we see it's going down. All right, so I would say that this is decreasing. Okay, I would just circle it. The reason why, you don't have to try to redo something. All right. Now, is it decreasing from 2 to 3? Well, here's 2 and here's 3. We're talking about this area right here. Okay, increasing or decreasing? Well, as we look, it's going up. So I would say this is increasing. Okay. Now, x-intercept, let's look, it touches here and here. We have two. We have the x-intercept, this could be x equals -1 and 2, or if you wrote it as a coordinate point, okay? And you kind of have to really read, like on the homework later, really read it, because this is a matching type thing, and for this problem, and it will say like coordinate or x value or y value. All right. Now, our y-intercept, where does it touch the y-axis? Well, that's right here at 0, -2. All right. Now, this part right here, I want to change this to something else. Well, yeah, let's do this hot pink. All right, evaluate f of 1. This is actually like function notation we had the other day, but it's the graphical version. Basically, what we do, we go over to the graph where x equals 1. Now, depending on the graph, you're either going to go up or down. The graph right here is down, so I'm actually going to go down here on that line, and that's where it touches. Well, what's that y value? Well, if you look right here, it's -2. Okay, again, all I did was go to the x at that number. I went to where the graph was, and I found what that y value was. All right, now the maximum. If we look, these have arrows. That means they keep going on forever. All right, your maximum is going to be infinity. Okay, it's going to keep going on and on and on and on. All right, now here's kind of the bad thing for this one, because this is a weird graph. The minimum. All right, this has these little 1, 2, 3, 4 hash marks. Okay, so it's like in decimals. This actually has a minimum of 0.5 and negative, too many commas, -2.25. Now, again, this is not such a great example, but we can actually see that there's hashes right there for the decimals. Nothing like that, anything anywhere else. All right, but this, again, is an example. All right, not too awful bad. Let's look at another one. All right, well, before we do that, axis of symmetry. We're going to get really into this when we get to Unit 9, or when we cover quadratics and we graph them and stuff. All right, it's basically a line through the shape, so it goes through. I will tell you this, all the axis of symmetries, oh shucks, go through the minimum. Okay, it cuts it completely in half. Judo chop right there. And it's a dotted line because it's not really there. I know it's imaginary. I don't know what to really say about that, but when we do start graphing, hopefully we'll be back in the classroom by then. It will be a dotted line. All right. Now, if you look at this graph, if you looked at the handouts, which you should have, this is a unique looking thing. This is what's called a piecewise. Okay, because it's a function that's in two different pieces. Okay, so so I got tickled myself. All right, I know whoever was naming this that day, they must have been like, "Oh, it's in two pieces, so let's call it piecewise." Okay. I don't think they kind of had people that talk like that in ancient Greece, but they probably did. All right, so the graph of increasing. So we're looking where it's going up as we look from left to right. Not there. This is actually going down. From here to here, it's actually going up. So it's going up between -2 and -1. That's the only little place it's going up. Okay. Now, our y-intercept, well, it only crosses right here at 0, -3. Our x-intercept, well, where does it touch this x-axis? Nowhere. This actually has none. Okay. Ta-da! All right. G of -2. Well, go to -2. All right, I look around. It's not below. This time it's above. So I'm going to go up. That's where it touches. I go over to that y value. It's 1. Now, for this one, it's kind of weird, but just hold on. The maximum, the highest point. Now, this is actually not the highest point because this arrow keeps going up. This actually has a maximum of infinity. Okay. And if you have a hard time drawing that, remember you can do an 8. Or write turn your paper sideways, do an 8, or something like that. As far as writing, we don't have to really write. All right. A minimum. Well, this arrow down here tells us that it keeps going down this way. So this actually goes to negative infinity because numbers keep going forever in a positive direction and a negative direction. All right, axis of symmetry. There is no way we can cut this thing in half. Don't say I can do this and it be the axis of symmetry. That's a no. Okay, so this is our axis of symmetry. No, I can't make that into 2 equal pieces. Okay. All right. Key terms. I mean, you should be able to answer these. Used to on the test, we give you a graph and you have to, there's 7 different things you could do. I mean, let's see, it's 5, 6. Yeah, there's 7 right here. And you only had to do 3. That's kind of a unique thing, but I would always focus on a few main things. So let's just look right here. All right, is the graph increasing from x equals 2 to 4? Well, here's 2 and here's 4. That line is going down right there. So it says, is it increasing? So we say no. Our x-intercept, well, that's here and here. X-intercept's at -1, 0 and 3, 0. All right, our y-intercept, where's it cross the y-axis? Well, right here, 0, 2. K equals -1. So I go to -1. It's right there. It doesn't go up nor down. So it's 0. All right, our maximum, our highest point is actually going to be right here. Our maximum is actually going to be 1, 4. Okay. And our minimum, if we look at our graph, it keeps going on forever in the negative direction. So it's a negative infinity. All right, is there axis of symmetry? Yes. You can actually cut this thing in half like so. And it actually divides it into 2 separate and equal, or it looks like the same. It's basically, if you've ever played with one of those mirrors where you like do half your body, that's really what it is. So if it is, it's draw it, and we did. Now I know unless you print these out, you can't draw it, or if you're using Kami or something, that would be kind of cool. All right. Now, your turn. If you have questions, this is when you would need to ask. I'm going to let you do this one as a practice. Okay. And you can say, Mr. Jeffries, I'll need to go over your turn from characteristics of graphs. And I'd pull this up and we would go from there. All right. And is that it? Looks like that's it. All right.